Hi students, welcome to Roots Academy. Myself Inayatullah, lecturer of mathematics. Students, in our previous video, we completed the chapter called inverse trigonometric functions. Now student, in today's video, we will start a matrices, which is very important in second PUC mathematics. So before we start anything, yes student, if you are new to our channel, don't forget to subscribe, and to helpful to your friends as well as other students, keep share and like our videos. So student, let us start matrices in today's video. Matrices. Student, it's very interesting and very easy chapter. Every student will find it's very easy because it has only addition, subtraction and multiplication. Student, in matrices there are many topics. First we will start with the definition. So student, what is matrix or matrices? Student, any arrangement, if we do it in row and column, then that kind of arrangements are called as matrix. Suppose I have elements A, comma B, A, B, A, comma B, comma C, comma D. I have these four elements. If I arrange these four elements in a row and column, then that kind of arrangements is called as matrix. How can I arrange? Let me check. A, B, C, D. Like this. Then we can see that this is the arrangement, or one more arrangement, A, B, C, D, or one more kind of arrangements, A, B, C, D. Students, these are the different arrangements if I have four elements. So students, these kind of arrangements are basically called as matrices. So student, here we can see that the elements of the matrix we write always between the brackets, between the closed or open brackets. We will use either this kind of brackets or we will use this kind of brackets. And the matrix we will represent it by capital alphabets, capital A, capital B, capital C, like this, and etc. etc. So student, what is the basic definition of matrix? Arrangements of elements in a row and column, then it is called as matrix. And the elements of the matrix we write between two brackets, and the matrix is represented by capital alphabets, A, B, C, D, etc. etc. So student, this is the basic definition of matrix. So student, wherever we can see the arrangements in row and columns, then that kind of arrangements we can call it as matrix. It can be arrangement of textbooks in our library. We will arrange the textbooks in the library in a row wise, in a racks, or wherever it is, not only in library, even if it is in our house also. So these kind of arrangements are called as matrix or matrices if it is more than one. So student, next, these are some basic arrangements with four elements. Next student, after the definition of matrix, let us consider here these horizontal lines or horizontal arrangements are called as row, and these vertical arrangements or lines called as columns. So always the horizontal arrangements or lines are called it as rows, and the vertical lines or arrangements are called as columns. For example, if I have a matrix B, its arrangements are like this. Suppose I have 9 elements. Now this time we'll take 9 elements. Okay, 4 I took already. Now we'll take 9. I will take numbers 3 minus 2 is 0, 4, 5 by 2 minus 1, 6, 5, 7 I will take. Any number. Now student, here it is a 9 elements arrangement, and these vertical arrangements, whatever these vertical arrangements are there, these I will call it as columns in matrix. These are the columns of a matrix. And here this is C1, C2, C3. That is columns. And these horizontal arrangements are called as row 1, row 2, row 3, rows. So vertical arrangements, columns; horizontal arrangements, rows. Understand? We can see here I written different kinds of numbers. It has positive, negative, fraction, everything. So student, in general, the elements of any matrix are real numbers. So the elements of any matrix are real numbers. Whatever the numbers we want, we can take. It is not necessary that we should take direct numbers. We can take even fractions, decimals, direct numbers, positive, negative, zero. Any kind of numbers we can take in matrix. So student, this is about the basic information about matrix. Now let us go to the next definition of matrix. That is order. The next definition in matrix chapter is order. So student, what is order basically? So student, order is number of rows into the number of columns. That is a definition of order. It is number of rows into number of columns. So student, this order tells about the number of elements present in a matrix. So for example, I have a matrix 5, 6, 8 minus 9. So I have a matrix. So if I want to know what is the order of this, then first I should check how many rows are there. First is rows. Then I should check how many columns. How many rows are here? 1 row, 2. These are rows. So its order has 2 rows. And how many columns are there? There are 2 columns here. So student, the order of this matrix is 2 cross 2. Let us take few more examples for order of matrix. For example, I have a matrix 1, 3 minus 4, 6, 0 minus 2, 4, 5, 9. So student, here how many rows are there? 1, 2, 3. So student, I have 3 rows here. So its order is 3. And then how many columns are there? 1, 2, 3. So it is 3 columns. So totally the order of this A matrix is 3 cross 3 because it has 3 rows and 3 columns. and this completely tells about the number of elements. If I multiply this 3 into 3, I'll get totally 9. So 9 is nothing but our elements of the matrix. And student, always the order of a matrix we write after the finish of the matrix, means at the end of the matrix, and that too it is below the matrix. We cannot write like this. We will not write 3 cross 3. See how I wrote? First matrix and here it ends. Then next below this I wrote the order. This is the order, not this. So what is the definition of order of matrix? Number of rows into number of columns of a matrix is called as order of matrix. With this order, we can easily come to know that how many elements are there in our matrix. For example, another example will take B matrix 1, 4, 5, 6, 0, minus 2. Now student, here, what is the order of this matrix? First we will always take rows, always rows first. How many rows are here? 3 rows into. Now how many columns here? 1, 2. 2 columns. So 3 into 2 is the order of this B matrix. That means how many elements should be there? 3 2 is 6. Yes, it has 6 elements. I'll take one more example here. 4 minus 5, 0, 8, 9, 1. Now student, what is the order of this matrix? How many rows? First rows must come 2 rows cross. How many columns here? 1, 2, 3. So it has 3 columns. So its order is 2 cross 3. Now let us solve some problems based on the order of matrix. Student, the first problem, if I know the elements of a matrix, then how to find its order? For example, if I said I have 15 elements in my matrix, I have 15 elements in a matrix, then what are the possible orders I can get? Let me check. The student, he said 15 elements in a matrix. Now he is asking us to find the number of orders. 15 elements in a matrix. Then what are the possible orders? Possible orders. Solution. So student, or what is the definition of order? I said the definition of order is number of rows into number of columns, and if you multiply all together, we will come to know how many elements are there in our matrix. But here he has given already how many elements are there in our matrix. So the orders are 1 cross 15, means it has 1 row and 15 columns, or the another possibilities are 15 cross 1, 15 rows, 1 column, or 3 cross 5, or 5 cross 3. These are the possible orders we can get with these 15 elements. So it means if you have a matrix with 15 elements, then the possible orders are any one among this, or 15 elements can be arranged like this. Next, the another question, if I have a matrix of 24 elements, in a matrix. That is, I have a matrix which is having 24 elements. Then what are the possible orders? What are the possible orders here? Solution. Okay, student, the possible orders are, it is 24. Let us take its multiple, that is 1 cross 24, 24 cross 1, 2 cross 12, 12 cross 2, isn't it? The next 3 cross 8, 8 cross 3, that is 8 rows, 3 columns. The next 4 cross 6, 4 rows, 6 columns, or 6 cross 4, 6 rows, 4 columns. Then next, yes student, these are the possible orders we can get if we have a matrix of 24 elements. These are its possible orders. So student, these type of questions they will also ask in your examination for 1 mark. Now students, another problem related to this. Suppose if I have a matrix of just 7 elements. I have a matrix with just 7 elements. Then what are its possible orders? What are the possible orders? Let us see how many orders can be formed here. With just 7 elements in a matrix. So the only possible orders are 1 cross 7 or 7 cross 1. That's it. These are the 2 possible orders we can get if we have a matrix with 7 elements. This is about the matrix and orders. Student, now we will discuss very important topic of the matrix, that is types of matrix, which is very important. They will ask 1 question for 1 marks in your board exam. So it's very important topic, and based on this we can solve most of the problems of matrix. So orders after order, types of matrix are very important. Let us discuss one by one. That is types of matrix. There are many types. We'll discuss one by one. First one, row matrix. Student, row matrix. As we discussed rows in order of matrix, that is horizontal arrangements or horizontal lines are called as row matrix. Or that is row. So here student, row matrix means a matrix which has single row. A matrix which has single row is called row matrix. Example, if A is a matrix, then 1, 3, 5, 6, 9. So student, here no need to bother about how many columns are there, but our concentration is towards only rows. How many rows are here? Single row. So that is 1 cross 1, 2, 3, 4, 5. 1 cross 5. So this is a row matrix because it has single row. The next one is column matrix. So student, what is column matrix? Obviously it is quite common. If you know row matrix, then column matrix is very easy to define. A matrix which is having single column is called column matrix. A matrix which is having single column is called column matrix. For example, B is a matrix. A, B, C, D, E, or you can take one more element, F. Student, so this is a column matrix because it has single column irrespective of any number of rows. So it has 6 rows but 1 column. So that's why it is called as column matrix. Any matrix which has single column, that is considered as column matrix. Next, third one, square matrix. Student, we know in square all the 4 sides are equal. That's one of the property of square. Now like that here, square matrix. So here student, in matrix obviously there are only 2 things, row and columns. So if you want to say any matrix is a square matrix, then the number of rows and the number of columns must be same. Then those kind of matrix are called as square matrix. Means a matrix which is having equal number of rows and columns. Equal number of rows and columns are called square matrix. Are called square matrix. Now how can I represent this? For example, if I have a matrix A, B, C, D. See student, this is square matrix because it has 2 rows and 2 columns. Another definition, B matrix, any number we can take 1, 0, minus 2, 0, 0, 4, 5, 6, minus 3, minus 2. Student, in this matrix, the number of rows are equals with the number of columns, and it is 3 cross 3. Its order is 3 cross 3. So this is also called as square matrix because in this matrix rows are equals with column. So whichever the matrix it is, if the number of rows are equals to the number of columns, then we will declare that as square matrix. Null matrix or zero matrix, or you can also called as empty matrix. Null matrix, zero matrix, or empty matrix. So student, here it's very easy. The name itself declares everything here. Zero matrix. A matrix whose all elements are 0. A matrix whose all elements are 0, then that matrix is called as zero matrix or null matrix. And student, zero matrix is represented by capital O, or you can call it as capital 0 also. Example, 0, 0, 0, 0, 0, 0. Check whatever the elements are, whatever the order here, irrespective of it, whether it is a square matrix or column matrix or row matrix. But as much elements are there, all those elements are 0 here, irrespective of any arrangements. I have 6 elements, all the 6 elements are 0, so it is called as zero matrix or null matrix. And it can be like this also. matrix here. Obviously, it is a square matrix, but here all the elements are 0, so it is called as null matrix. So, a matrix whose all elements are 0 are called null matrix. Next, diagonal matrix. Student, diagonal matrix. Student, in matrix, if exactly we want to divide a matrix into two equal parts, suppose if we want to cut a matrix into two equal parts, then the only possibilities is we should cut this by diagonally. We should cut this by diagonally. So here, this elements, that diagonal, this from left to right, this kind of diagonal is called as principal diagonal elements. This is called as principal diagonals here. Principal diagonal. Now, student, in diagonal matrix, first it must be a square matrix. Diagonal matrix must be a square matrix. First thing here. Okay. After that, student, only the principal diagonal elements must present. Only the principal diagonal elements must present, and all other elements must be 0. That means here, if I have a matrix 1 0 0 0 2 0 0 0 3. So, student, first of all, this is a square matrix. Then only the diagonal elements present here, and upper diagonal elements and lower diagonal elements are 0. So, this kind of matrix are called as diagonal matrix. And student, in a matrix, the upper elements of the diagonal is called upper diagonal elements, and the lower diagonal elements are called lower diagonal elements of a matrix. So, student, here in diagonal matrix, the principal diagonal elements must be different. It cannot be same. It must be totally different. Any one element may repeat. One element can be repeated, but in general, all the three elements must be different. So, another example. Student, here in case of 2 cross 2, see, this is the principal diagonal element, and other than these principal diagonal elements, all elements are 0. So, this is also called as diagonal matrix. Next, identity matrix, or you can call it as unit matrix. Identity matrix or unit matrix. So, student, identity means, it is, or unit means it is one single. So, here, student, first again, this also must be a square matrix. It must be a square matrix. If there is no square matrix, then we cannot define identity. So, to define identity matrix, first we should have a square matrix. Then, in a square matrix, the principal diagonal elements must be 1. The principal diagonal elements must be 1, and all other elements are 0. Example, 1 0 0 0 1 0 0 0 1. Now, student, here I have taken a 3 cross 3 matrix. its order is 3 cross 3, 3 row, 3 column. So we can easily check that here. In this, the principal diagonal elements are 1, not same. Just it must be 1 only. If other than 1, if you write any element, it is not identity matrix. For identity matrix, the principal diagonal elements must be 1. And of course, all other elements are 0. Then those matrices are called as identity or unit matrix. In case of 2 cross 2, it will be like this. And student, in general, the identity matrix is represented by capital I. In general, the identity matrix is represented by capital I. So I cannot write A, B here. Just to give an example, I written A and B are the name of the matrix. But in general, it is represented by I. As for null matrix, will represent 0. So like that, identity matrix be represented by capital I. If it is 3 cross 3, it should be like this. If it is 2 cross 2, it must be like this. Next, 7th one. Scalar matrix. Scalar matrix. Student, what is scalar matrix? Student, here in scalar matrix also, it must be a square matrix first. It must be a square matrix. Then after this, student, the principal diagonal elements of a square matrix must be same or equal, and other elements are 0. Then those matrices are called as scalar matrix. Example, if suppose A is the matrix and I have like this A 0 0 0 A 0 0 0 A. Student, it is 3 cross 3 here. I wrote a general matrix instead of numbers. I wrote a general matrix, and you can easily see that in this matrix, the principal diagonal elements in this matrix, all the principal diagonal elements are equal. It can be anything. It can be 1, 2, 3, minus any number, but all the 3 numbers must be same. If any number is different, then it is not a scalar matrix. The first case is it must be a square matrix. Then the principal diagonal elements must be equal and other elements are 0. This kind of matrix are called scalar matrix. In 2 cross 2, in case of 2 cross 2, it is, for example, if I take any number, minus 3, 0, 0, minus 3. Student, we can check here. See, the principal diagonal elements are equal or same. Other elements are, that is upper and lower principal diagonal elements are 0. Now student, as I said, these elements must be equal. I said equal. I can take any number here then. In case, if suppose, if I take like this, if I take like this, is this a scalar matrix for us? Yes, of course, it is a scalar matrix, no doubt about it, because it is a square matrix. Good, it is a square matrix. Then after that, the principal diagonal elements are equal. Okay, yes. See, here all 3 elements are equal. But actually we will call it as identity matrix. This will call it as an identity matrix. Then what is the conclusion then? What we can understand with this identity and scalar matrix? mean then the final conclusion we can give by comparing these two matrices is every identity matrix is a scalar matrix, but student, see, every identity matrix is a scalar matrix because the principal diagonal elements are equal, but scalar matrix is not an identity matrix. But scalar matrix is not an identity matrix because, as I said, the principal diagonal elements must be equal in scalar. Then it can be like this also. Yes, it can be like this. Yes, see here, the principal diagonal elements are equal. It is a scalar, but it is not identity. Here, it is a scalar as well as identity. So the conclusion is the identity matrix is a scalar matrix, but scalar matrix is not an identity matrix. This is a very important statement. Equal matrix. Equal matrix. So student, here equal means we are comparing with something, then only we can say it is equal or not. So equal matrix means, let us take two matrices here. To understand the definition of equal matrix, let us take two matrices. I will take A and B. Student, A matrix is A, B, C, D, and the B matrix is A, B, C, D. So student, first, to declare any two matrices are equal matrix, then we should check first the orders are equal. First thing we should check is orders of the two matrices are equal. Yes, here orders are equal. Both are 2 cross 2. Then second case, the corresponding elements of the two matrix. The corresponding elements of the two matrix means first element of first matrix must be equals with first element of second matrix. If the correspond like that, we should check for all the elements. If any element is different, any corresponding elements is different, then it is not equal matrix. So when can we say two matrices are equal? First thing, orders are same. Both the matrix should have same order. Second, corresponding elements of both the matrix are equal but same. Then we can declare that the two matrices are equal matrix. For example, students, if I have a matrix like this 1, 2, 3, 4 and B is a matrix 2, 3, 4, 1. So students, actually it is the very best example. First thing is orders. What is the order of this? 2 cross 2. What is the order of this? It's also 2 cross 2. Okay, orders are same. Next, second case, what we should check? The corresponding elements of both the matrix. are equal or not, we should check. First matrix, first element is 1 here. Second matrix, first element is 2. So 1 is not equals to 2. With this itself, we can declare that it is not equal matrix. Of course, other elements are also there, but no need to check much. So here A is not equal to B. Though the orders are same, what happened here? The corresponding elements are not equal. That's why these are not equal matrix. So another case. Next, if 1, 2, 3, 4, 5, 6. Another matrix, B matrix, 1, 2, 3, 4, 5, 6. Now student here, obviously there are 6 elements here, and here also we have 6 elements. But what is the order of A matrix? 3 cross 2, and here it is 2 cross 3. Student, no need to even bother what about the corresponding elements here. We just came to know that orders of the matrix are totally different. A matrix order and B matrix orders are totally different. With this, we can give a conclusion that these two matrices will never be equal matrix. These two matrices are totally different. So how can we say, when can we say that two matrices are equal? The first thing for that is orders of the two matrices are same. Then the corresponding elements of both the matrix must be equal. All the elements must be equal. If any one element is different, then it is not an equal matrix. Student, will take transpose of matrix or transpose matrix. Transpose matrix. Also transpose. The related word of transpose is transfer, transferring or changing. Student, transpose. If suppose A is a matrix, then its transpose is represented by A dash or A power capital T. In general, the transpose is represented by dash or power T. But most of the authors or lecturers prefer A power dash, A dash for transpose. So what exactly happens in transpose? In transpose, we will interchange the rows and columns of the matrix. For example, I have a matrix 1, 3, 6, 5, 0, minus 7, minus 8, 1, 2. Student, A is a matrix and its order is 3 cross 3. In transpose, what I said? Transfer. So what can we transfer in matrix? There are only two things in matrix. One is a row, other is a column. Then definitely if at all we want to transfer, only these two things we can transfer. So the transpose of this A matrix is represented A dash. Then here, if I am writing the transpose of this matrix, then what exactly I should do? The rows should be converted to columns. All rows should be converted to columns. Then definitely columns will convert to rows. So 1, 3, 6, 5, 0, minus 7, minus 8, 1, 2. So student, this is the transpose of this matrix. So what exactly we did in transpose of matrix? We interchange the rows to columns. So this is called as transpose of matrix. If we interchange rows to columns and columns to rows of a matrix, then the new matrix is called as transpose of matrix. And here it is not necessary that the order should be 3 cross square matrix. It can be anything. Another example, if I have a B matrix like this, A, B, C, D, E, F, then student, its transpose is represented like this, B dash. If B is matrix like this, then its transpose will be B dash. And as I said here, transpose means interchanging the rows and columns. Changing the rows to columns. Okay, I have first row here. This will become column A, B, C. Then second row becomes second column D, E, F. So this is transpose of this matrix. Definitely orders will also change if we take the transpose. Not necessary that we should get same order. Now in case of square matrix, we get same order. But in case of rectangular matrix or some other matrix, we get different order, as we can see here. So its order is 2 cross 3. Here its order is 3 cross 2. So student, what is transpose matrix? In any matrix, if we change rows to columns and if we convert columns to rows and rows to columns, is called transpose matrix. Next, symmetric matrix. Next is symmetric matrix. Student, what is symmetric matrix here is any matrix if it is equals to its transpose. Any matrix equals to its transpose, then a matrix is called a symmetric matrix. Let us check, is it possible, really possible? Because any matrix should be equals to its transpose also. If that case is that is possible in any matrix, then that matrix is called symmetric. Let us check. If I have a matrix 1, 2, 3, 2, 4, 5, 3, 5, 6. Let me try to take the transpose of this matrix. Basically, it is represented by A dash. This is the first row, first column. Next, this is the second row, 2, 4, 5, second column. Next, third row, third column. Let us check, is these two things are equal? 1, 2, 3, 1, 2, 3, 2, 4, 5, 2, 4, 5, 3, 5, 6, 3, 5, 6. Yes, student. We got A equals A transpose. Now, student, then this matrix, this A matrix, is called as symmetric matrix. Called as symmetric matrix. So, what is the definition of symmetric matrix? If matrix is equals to its transpose, then it is called as symmetric matrix. And in general, it must be a square matrix. It must be a square matrix, then only it is possible. If it is not a square matrix, then obviously orders will change. So the first thing we should check, if you are checking symmetric, it must be a square matrix. In otherwise, it is not possible. So this is the definition of symmetric matrix. A equals to a transpose. And student, the one more property of symmetric matrix is, if you check this thing or even this matrix, the one more beauty of this symmetric matrix, upper diagonal elements and lower diagonal elements are exactly equal. Here, this is the lower diagonal element. lower diagonal elements, and these are upper diagonal element. See, both are equal. The first element of upper diagonal element is 2. The first element in the lower diagonal element is 2. The second element is 3 here. Here also it is 3. And third element here is 5. Here also the third element is 5. So if a matrix is symmetric matrix, then the upper diagonal and lower diagonal elements are equal. So we can easily understand whether it is a symmetric or not with this property. Next, the last one is skew symmetric. Skew symmetric matrix. Student, here in general this matrix must be a square matrix. This must be a square matrix. And what is the skew symmetric matrix, student? Student, in any matrix, in any square matrix, if it is equals to its negative times of its transpose, then it is called as skew symmetric matrix. That means A should be equals to minus A transpose. A should be equals to minus A transpose. Then A is called as skew symmetric matrix. So I'll repeat the definition of skew symmetric. Any square matrix, if it is equals to negative times of its transpose, then the matrix is called as skew symmetric matrix. Then let us check, is it any matrix like this? If suppose A is the matrix 0, 3, minus 4, minus 3, 0, 5, 4, minus 5, 0. Okay, student, this is the 3 cross 3 matrix. Then its transpose is A dash, because A is the matrix. If I take B, then definitely I should write B dash. Okay, transpose, we know what exactly we should do. Rows converted to columns. So 0, 3, minus 4. First row becomes first column. Now second row becomes second column. Minus 3, 0, 5. Then last row become last column. 4, minus 5, 0. So student, is A equals to A transpose? Here, let us check. So student, if I multiply negative to A transpose, then let us see what I will get. 0 doesn't have any sign. Minus into minus becomes plus. Plus into minus becomes minus. This becomes minus. This becomes plus. This becomes plus. This becomes minus. Yes, student. Then with this two things I can compare that A equals minus A transpose. Now student, this A matrix is called as skew symmetric matrix. And student, here if you are checking a skew symmetric matrix, then it has one property that is a very special property in types of matrix, because in skew symmetric matrix the principal diagonal elements must be 0. The principal diagonal elements must be 0. This is the only speciality in skew symmetric matrix, where in case of any other matrix the principal diagonal elements are not 0 except 0 matrix. And one more thing here, the upper diagonal elements and the lower diagonal elements here, the upper diagonal elements and the lower diagonal elements must have different in sign. Numbers are same, but it has different in sign. one has negative, if this is the first element in upper diagonal element, this has positive sign. If this has positive sign, the second element here it should have negative sign. And if this is negative, then this should have positive sign. These are the two things we should check in skew symmetric matrix. So what is the first thing we should check? The principal diagonal elements must be 0 and the upper diagonal elements and lower diagonal elements must be same with different signs. With different sign. First element is 3 and here it is minus 3. It should be like this. If it is minus 4 here, then this should have be plus 4. And if this is minus, this is plus. And the exact definition is A equals negative times of its transpose. It's called skew symmetric matrix. So student, these are the basic types of matrix which are very, very important. So student, anyone they will ask in your final examination. So student, if you have any doubt in these types of properties, you can put your doubt in comment box. I hope you people understood today's concept. Thank you, student.